In this video, we are going to learn how to solve polynomial inequalities. So first of all, you'll notice that this particular polynomial is already in factored form. If it was not, we would want to factor it first. Now that it's factored, let's decide where the factors each make the inequality equal to 0 so that we can then figure out where together their product is greater than 0. So if I take each factor and I set it equal to 0 so that I can find where those points will be on the x-axis, I have one point at 9, and I have another point at -2. So if I'm looking at my x-axis, we have one point at -2, and we have another point at 9. So basically, this is going to break our x-axis into what we call 3 different intervals. And sometimes they'll have you look at just values of a sign on the interval. So I'll do that first, and then we'll also talk about the graph and what you might know from the graph. So if I look at I'm going to go from left to right, the first interval that starts at -infinity and goes to -2. If I take a test point and I simply plug it into the original inequality, so let's just use a test point of, let's say, x equals -5, since that would be on that interval, then what I know is that if I have -5 minus 9, that's a negative number, and -5 plus 2, that's also a negative number. A negative number times a negative number would give me a positive number. So my sign on that interval would end up being positive. If I choose a test point in the second interval that runs from -2 to +9, again, doesn't matter what test point you choose. I'm just going to choose 0 since it's easy to plug in. When I plug that into my original polynomial, I get 0 minus 9, which is a negative number, and I get 0 plus 2, which is a positive number. So overall, a negative times a positive would give me a negative sign on that interval. And then finally, when I do the same thing on my last interval, which runs from 9 to +infinity, choose any test point that you want. I could choose something such as 10. When I plug that in, 10 minus 9 is positive. 10 plus 2 is positive. So a positive number times a positive number would be a positive number. Now, we are specifically interested in where this inequality is greater than 0. And so greater than 0 is just a fancy way of saying that it is positive. And so when we're looking at our actual graph, we saw that it was positive on this interval and that it was positive on that interval. And of course, because it does not say equal to 0, we are not including those particular endpoints. So there would be open circles at those endpoints because it does not say equal to 0. Now, when you're actually asked to officially write the solution, you're going to give interval notation. So you'll notice that where I have shaded here starts at -infinity, goes up to -2, but does not include it. So we close with the parentheses, and then we put a union symbol, and then our shading once again starts close to 9, but does not touch it. So we put a parentheses, and then it goes to infinity. So that's how we would write our solution. And then, of course, this would be our graph. Now, the other thing that you can do, or that I like to do, is I just like to think about the graph. And so if I were thinking about this particular graph, I know that it has x-intercepts at -2 and over here at +9. And this particular polynomial, if you were to multiply those factors out, would be a quadratic, and it would specifically be a quadratic that is opening up. And of course, going through those x-intercepts. And so When we're asking where is that quadratic greater than 0, that's just another way of asking where are the pieces of the graph above the x-axis. And so you'll notice that they are above the x-axis to the left of -2, which matches what we shaded on the original graph, and that we're above the x-axis to the right of 9. So you can also think of it in terms of the graph. Okay. Notice on our next inequality, it is not in a factored form. So the first thing that we would want to do is to factor it. So if I think of, in this case, factors of 35, first let me break apart. X squared is just x times x. And I think of factors of 35 that can add up and give me -12 in the middle. My factors are going to be 5 and 7. And their signs would have to both be negative. And so again, we can think about our different intervals and the signs. So if I go ahead and do a number line, look at the values that make each factor equal to 0. So you would have a value of 5 that makes the first one equal to 0, and a value of 7 that makes the second one equal to 0. So that kind of partitions our graph up into 3 different intervals. And so if you want to do the test points, for example, if you plugged in x equals 0 over here, you would have 0 minus 5, which is negative, times 0 minus 7, which is also negative. So negative times negative would be positive. In the middle, you could use something like x equals 6. So 6 minus 5 is positive, but 6 minus 7 is negative. So overall, positive times negative is negative. And then over here, you could use something like x equals 10. So 10 minus 5 would be positive, and 10 minus 7 would be positive. So overall, that would be positive. Now, in this case, we are interested in where this particular graph or the polynomial is less than or equal to 0. So we're interested in the negative portions, which would be in between. And since it also includes equal to 0, that would include the endpoints this time. And so in terms of our solution, we would say it is the interval that starts at 5 and ends at 7. And since we're including the endpoints, we use square brackets on those intervals to show that they are included. And then, of course, once again, if you wanted to instead just think of the graph, this particular polynomial is a quadratic who has x-intercepts at 5 and 7. It is opening up since it's a positive x squared. And so the graph would look something like that. And we are specifically interested in where this particular graph is less than or equal to 0. So that means we're interested in where does it fall below the x-axis. And so as you can see, and like we've already shaded, it is falling below the x-axis in between my positive 5 and my positive 7. And it is including those endpoints, just like we graphed above.